Good morning, class. We are looking at exam 4 review, covering from 4.4 to 5.4. Optimization problems, antiderivatives, the fundamental theorem of calculus, and the substitution. So first, let's look at some integration formulas, anti-differentiation, the reverse process of the derivative. FTC, short for fundamental theorem of calculus. The derivative of the integral of a to x f of t dt is f of x means if you take the integral and then differentiate it, you get the function back at the upper limit. The integral of a to b f of x dx is f of b minus f of a. This is a definite integral. And the substitution rule, that is the reverse process of the chain. Now, to discuss optimization problem, first I want to discuss the first or second derivative test for absolute extreme. A local extremum is an absolute one if it is the one and only one extremum in an open interval. So if you have a open interval and one critical point, it's not only local, it's also absolute. But whether it's max or mean, you have to do the first or the second derivative test. For example, find two numbers whose sum is 54 and whose product is a maximum. That means you have to define the variables. The two numbers, let's say they are x and y. You want to maximize the product p equals x times y. And the constraint is the sum x plus y must be 50. If 5400 pi inch squared of metal is used to construct a cylindrical storage drum, what is the maximum possible volume? So you should know the shape. You should know the volume that you want to maximize is pi r squared h. Here's the radius, here's the h. And now the constraint is that this much material, meaning gift wrapping, the area of the base is pi r squared. You have two of them, the top and the bottom are identical. And the surrounding, if you cut this open, the circumference becomes the width. And of course, the height remains unchanged, h times that. So 2 pi r h becomes the rest of the area. So we write it's subject to constraint S, standing for surface area, 2 pi r squared plus 2 pi r h, which is supposed to be 5400. A farmer has 2400 feet of fencing. This is what we are going to quickly look at. And wants to fence up a rectangular field that borders a straight river. He needs no fence along the river. What are the dimensions of the field that has the largest area? You must draw the setting and define your variables. So here's the setting. Here's x representing the width. Here's y representing the length. You want to maximize the area, x times. Subject to 2400 feet of fencing, normally the perimeter is 2x plus 2y. This side doesn't need it, so 2x plus y is 2400. You solve for y. You put it into a, becomes a function of one variable now. A is x times 2400 minus 2x. And x must be between 0 and 1200. Why is that? Because first of all, x represents dimension must be positive. Secondly, if you set this one equal to 0, x becomes 1200. Why it is less than that? Because if you pick a number larger than 1200, this becomes negative. And so a of x is 2400x minus 2x. So far, everything we've done is elementary algebra. And now the calculus begins. We want to find the critical point. A prime is 2400 minus 4x. You set that equal to 0 in order to find the CP, or the critical point. X becomes 600. So you have an open interval of 0 to 1200. You have one critical in between. So this is not only going to be a local, but absolute. But is it max or mean? Well, the second derivative minus 4 You have to evaluate the function at this x, but this is independent of that. You recognize it as negative. That means it's concave down. That means it's maximum because concave down looks like this. So the maximum occurs when x is 600. You put it back into this to find y, 1200. So the dimensions are 600 by 1200. What is the largest area? The product of the two, 720,000 square feet. All right, we are ready to move on. Here's another optimization problem. From a thin piece of cardboard, 10 by 10 centimeters, square corners are cut out so that the sides can be folded up to make a box. What dimensions will yield the box of maximum volume? What is the maximum volume? Draw the setting. So here's a 10 by 10. We're going to cut the X amount from each corner. That means right here is 10 minus 2x folded up, and the dimensions are as follows. So what is the objective is to maximize the volume, a rectangular solid, length times the width times the height. And now this setup gives us the constraint. The width and the length are the same, 10 minus 2x, and the height is x. Replacing them, make it a function of one variable x. So v of x is x times 10 minus 2x, quantity squared. X must be between 0 and 5. Why is that? Two ways to look at it. If this is 10 by 10, if you fold it in half, it becomes 5 on each side, and you can't create a box. If you set this one equal to 0, x becomes 5. And because it represents a dimension, if you go larger than 5, becomes negative. So you can't have it. Now, to work on this, we're going to raise this to the power of 2. 10 squared is 100. 2 times this times that is minus 40x, and square this one, we get 4x squared. And when we multiply by x, we get 100x minus 40x squared plus 4x cubed. I'm going to put the 4x cubed first, put it in descending order to get it ready for the next step, which is differentiation. So everything we've done again has been algebra so far. Now the calculus v prime is 4 times 3, 12x squared, minus 40 times 2, minus 80x, plus 100. So v prime of x, 12x squared, minus 80x, plus 100. Because we want to set this equal to 0, we are going to factor it. We notice there's a common factor of 4. The GCF is 4, take it out. We get 3x squared minus 20x plus 25. Now to factor this 3 is a prime number. It's just 1 and 3, so 3x and x. 25 is 1 times 25 or 5 times 5. Both of them must have the same sign, positive or negative. So factoring with the trial and error ends up being 4 times 3x minus 5 times x minus 5. The reason we set it equal to 0, because we are looking for CPs, critical points. This gives us 5/3. This gives us 5. And when we go back here, x can't be 5. So you have an open interval of 0 to 5. With one critical point. Let's see if it's going to maximize or minimize. We go with the second derivative test. V double prime is 24x minus 80. The second derivative test says, plug in the critical point, see if it's positive or negative. Positive is concave up, negative is concave down. We just want to look at that. So let's plug in. When we do that, this cancels out this one, we get 8. 40 minus 80 is negative 40. And understand, we just want the sign. Negative means concave down, means maximum, because this is the shape of a concave down. So maximum occurs when x is 5/3. We put that into width equals length equals 10 minus 2x. This is 10/3. So we write this one as 30/3. Their difference is 20/3. And there you have it. The dimensions are 5/3 by 20/3 by 20/3. What is the maximum volume? Multiply these numbers. 5 times 20 times 20 is 2000. 3 cubed is 27. This is an exact answer. And this is a mixed number format. And it's important to know the units, okay? Cubic centimeters, because we are looking at the part. Find all functions g such that g prime is 4 sine x plus 2x to the power of 5 over x minus square root of x over x. So what is the process? Solution. Sometimes you will need to simplify first. Factor, cancel, remove radical notation, etc. Sometimes we will need to integrate using substitution. So in this case, we make up two fractions. This one is 2x to the power of 4. This one is minus square root of x over x, which is x to the power of 1/2. So this remains, this is 2x to the power of 4, and this is x to the power of 1/2 minus 1 or negative 1. So what is g of x? Is the integral of the right side times dx. Don't forget the dx. So the derivative of sine is cosine. The integral is negative, so minus 4 cosine x. This one uses the power rule, 1 over n plus 1 x to the power of n plus 1. So 2 over 5, because the exponent is 4. 2 over 5 x to the power of 5. This one negative 1/2 is the exponent. So minus 1 over negative 1/2 plus 1, x to the power of negative 1/2 plus 1, and a constant. This means 1/2. This means 2. So minus 2 x to the power of 1/2, which is minus 2 square root of x. And that's the final answer. All right. We're going to integrate, and we are going to do term by term, which means this one, the exponent is 4. We take it up, we make it 5. So 2 over 5 x to the power of 4. This one, take it up, make it 4. 3/4 x to the power of 4. Take it up, make it 3 minus 7/3 x cubed. This one again, as you recall, when x is given, the exponent is 1. So 1/2 x squared minus 5x plus a constant. The integral of x minus 5 quantity squared dx, we better raise this to the second power using a minus b quantity squared, which is a squared minus 2ab plus b squared. So this is x squared minus 10x plus 25. This gives you 1/3 x cubed Again, this one has exponent 1, so minus 10 over 1 plus 1, or minus 10 halves, or minus 5 x squared plus 25x and a constant. When we deal with exponentials, the derivative and the integral of exponentials is always itself when the base is e. However, in the case of differentiation, you multiply by k, if you call this k, and in the case of integration, you divide by k. So the answer is itself divide by k. So divide by 4 and a constant. In this case, the answer is itself. Divide by negative 3. Division by negative 3 means negative 1/3 e to the power minus 3x and a constant. We rewrite this as half of x, so it becomes clear that you're dividing by 1/2, meaning this becomes 1 over 1/2 e to the power of x over 2 plus a constant. Just, I want to make sure this is clear that this number is 1/2, so this is obviously 2. So 2 e to the power of x over 2 plus a constant. Now, we want to deal with 1 over x or x to the power minus 1, which results in a natural log. And if you recognize this as 2 times 1 over x, you don't have to write that, but it's a good practice to write it so when you go back to it anytime, it makes sense to you that it's 2 natural log of absolute value of x plus c. And in this case, again, we rewrite it. So we recognize the 1 over x. So the answer is 1/2 natural log of absolute value of x plus a constant. We are dealing with definite integrals. The integral of a to b f of x dx is capital F of b minus capital F of a. So to integrate this, we're going to write the 1 of the antiderivatives, 1 over 8 x to the power of 8. And the reason we write one of them and we don't need the constant, even if we write plus c makes no difference. 1 gives you 1, 0 gives you 0, 1 over 8 in front remains. The answer is 1 over 8, and here's the tip. Even if we use another antiderivative, capital F of x plus c, in the evaluation theorem, the result will be the same. So capital F of b plus c minus capital F of a plus c, those cancel each other, so we get the same thing back. In this case, I want you to recognize this as 1 over x, and therefore the result is a natural log. Plug in. We should know ln1 is 0, and ln2 is the exact answer, and we're done. Now, this question is similar to that. So what is the difference? So we're going to write the same thing with different limits. The difference is the limits in part B, they are all positive. So we lost the absolute value sign. Did they make any difference? But now you must keep the absolute value sign because natural log of a 0 or negative number is undefined, doesn't exist. So ln of 1 minus ln of 2, since ln of 1 goes to 0, the exact answer is minus ln2. The integral of 0 to pi sine x dx, the derivative of sine is cosine, the integral is negative cosine. And so to evaluate this, let's keep the negative out and plug in cosine of pi minus cosine of 0, and the cosine of pi is negative 1 minus cosine of 0 is positive 1. So the brackets become negative 2. The negative outside makes it a positive 2. To integrate this, we make up 3 fractions. And to make sure we can handle this, the second piece, minus 7 over x, we write it as minus 7 times 1 over x. And the third piece, 2x to the power minus 2. So we get them ready for the next step. Clearly, the derivative, the integral of 1 is x. The integral of negative 7 times 1 over x is negative 7, natural log of absolute value of x. And now this one is 2 over negative 2 plus 1, x to the power of negative 2 plus 1, which makes it minus 2 over x, or minus 2x to the power minus 1, which is minus 2 over x, and a constant. The independent variable is t. So 1 gives you t. Cosine, the derivative is negative, but the integral is positive sine t. Minus secant squared. Tangent, the derivative is secant squared. So the integral of secant squared is tan t. So minus tan t and a constant. Change the cube root to x to the power 1/3 to get it ready for the power rule. So 1 over 1/3 plus 1, x to the power of 1/3 plus 1, minus the derivative of sine is cosine, the integral is negative cosine. So minus negative cosine x plus c. So the first thing I want to refer, of course, this becomes positive. This is 4/3, everybody. So when you divide 1 by 4/3, that means the reciprocal of that. 3/4 of x to the power of 4/3, we rewrite it as 3/4 of cube root of x to the power of 4 plus cosine x and a constant. Initial value problem. So what is an initial value problem? Recall, any equation containing a derivative is called a differential equation, or DE. So everything we've done with regards to integration is really solving differential equation. A function which satisfies the equation is called a solution to the differential equation. An initial value problem is a differential equation along with a specified value of an unknown function called the initial condition. So this part is basically what we have been doing, and we're going to work on it. We're going to come back to this point. So dv is the right side times dt, and if you integrate both sides, this becomes v of t. Exponential, the answer is always itself. This one we divide by -1, which is the same as multiplication. This one is itself and a constant. And that gives us v of t, which is a general solution. So if we didn't have this, which is a pair, which makes it an initial value condition, we would be done. But we do have the pair. We replace the independent variable t with 0 and the dependent variable y, or in this case v of t, with 3, and we plug in. E to the power of 0 is 1. These two cancel each other, so c becomes 3. And therefore, in this function, we replace the c, and This, everybody, is a general solution. This is a particular solution. Now, understand this means it's a family of functions because of plus c, infinitely many functions. The effect of c is to go up and down along the y-axis. And this one, when we used one pair, we could figure out what c. So one of those functions, that's why it's a particular solution. The integral of 2x times x squared plus 5 quantity cubed, we are going to use the substitution method. The tip is look for a function u equals g of x anywhere in the integrand, and its derivative du or g prime of x multiplied by dx. When you have polynomial functions, the more complicated one, in this case x squared plus 5, is the choice of u. Notice its derivative, du dx is 2x, which makes du equal to x dx. Now, I'm going to move things in a manner that it becomes clear. This is u, and this is du. So you have u cubed du. And that means the power. So 1/4 u to the power of 4 and a constant. And u can be replaced with x squared plus 5, the reverse substitution. That's the final answer. Let's do this, and I want you to see them side by side. Both of them are fractional format. More specifically, those are rational functions, but they don't even have to be rational functions. The process is the same. Number one, you want to try to simplify a rational function, which means if you can, or a fractional format, if you can find a common factor between the top and the bottom, you want to drop it. This one can be factored. 2 is a prime number 1 and 2. 3 is a prime number 1 and 3. One of them must be negative, and it becomes 2x plus 3 times x minus 1. However, this doesn't simplify everybody. So I'm going to put the dx at top. There is nothing to do here. The denominator is the choice of u. The derivative is 4x plus 1, which makes du 4x plus 1 times dx. Put the dx at top, and you can see du over u, which is natural log. Replace the u, and you're done. Bear in mind, the absolute value we keep, because this expression can be positive, can be negative. So what's the difference between these two? Why do we have them next to each other? Well, I can factor the top. When I factor the top, I can drop the common factor of x minus 1. So that's the difference between the two. I can't do anything here. I can't simplify it, but this I can and I must. That's the difference between the two. The denominator this time is 2x plus 3 is the choice of u. Its derivative is 2, therefore du is 2 dx, and The numerator is 4dx, which is 2 times 2dx. I want you to notice that. 2 times 2dx. So there is, again, du over u, which means this part is a natural log. Keep the 2 outside or in, makes no difference. It's a multiplier. And reverse substitution, you have to change the u to 2x plus 3. And 2 natural log of absolute value of 2x plus 3 plus c is the final answer. And you have to keep the absolute value because it can be positive, it can be negative. So what's the difference between these two? This can be simplified, this cannot. Let me look at the reciprocal of part B, and that is 2x squared plus x minus 3 over 4x minus 4, which means this is the reciprocal of that. So the answer is the reciprocal of this, right? Because we can factor it. So instead of 4 over 2x plus 3, now we have 2x plus 3 over 4 dx. And what's the difference? Well, make up 2 fractions. This is half of x. This is 3/4. We do not need the substitution method. That's the difference, everybody. So the integral of x is half of x squared. With this 1/2 becomes 1/4 x squared. This is 3/4 x and a constant. The final answer.